Okay. So today we're going to talk about cloud architecture. That's module 9. Right. And the topics is the AWS well-architected framework, reliability and high availability, AWS trusted advisor, and activities, design principles, and interpret AWS trusted advisor recommendations. Right? After completing the module, you should be able to describe the AWS well-architected framework, including the 5 pillars, identify the design principles of the AWS well-architected framework, explain the importance of reliability and high availability, identify how AWS Trusted Advisor helps customers, and interpret AWS Trusted Advisor recommendations. Okay? So let's talk about the first section. AWS well-architected framework. Okay. So, architecture is the art and science of designing and building large structures. Right? So large systems require architects to manage their size and complexity. For example, cloud architects, they will engage with the decision makers, right? Decision makers to identify the business goal and the capabilities that need improvement. They will ensure alignment between technology deliverables of a solution and the business goals. And they will work with delivery teams, right here, delivery teams that are implementing the solution to ensure that the technology features are appropriate. So having the well-architected systems greatly increases the likelihood of a business success. Okay. Just like when you build the building and you have the structure design in it and the complete design, this is the same thing that you are trying to accomplish when you are architecting in the cloud. Okay. Now, what is the AWS well-architected framework? Well, it's a guide that is designed to help you build the most secure, high-performing, resilient, and efficient infrastructure possible for your cloud applications and workloads. It will provide a set of foundational questions and best practices that can help you evaluate and implement your cloud architectures. So AWS developed this well-architected framework after reviewing thousands of customers' architectures on AWS. Okay, so all of this are things that are provided in the well-architected framework. It just help you, design securely with high performance, resiliency, and efficiency. Okay. All of the things that are contemplated or are included in the well-architected framework are from best practices from other people that have developed architectures, and AWS took that from them by reviewing the customer architectures. Right. Now, this is the most important part of this well-architected framework. It's the 5 pillars. Okay, the 5 pillars. These are the things that you have to consider when architecting. If you are being compliant with this and you're going by the best practices using this pillar, then everything's going to be fine for you, right? So we have the operational excellence, security, reliability, performance efficiency, and cost optimization. Okay. They're going to show in the exam somewhere, somehow. Okay. If you have taken exams, the ones that I posted on Slack, I don't know if you guys have seen Slack, right?
Yes, they're in the exams.
So if you take a look at our exams, you're gonna
It
see that
says,
there's one channel that I created, and all the exams are there. Okay. So the only thing that you have to do is click on this guy, and then you can take these exams as many times as you want. Okay.
are
And
the same exams that you send by email, yeah? Every day.
they are the same. They are the same. Same exams. I decided to post them here because the email would take 1 day, right? I just put there are all of them open, so I post them here so you guys can take them as many times as you want. I recommend taking exams, and until you feel comfortable with 90 or above. Okay, 90 or above. If you continue
For each of them or for any of them?
for each of them. So if you get 75, push harder and increase that score to 90 or more until you feel comfortable. Okay.
Excuse me, could you change or could you send me the link, because I'm not, or add me to the channel, so I don't see that channel.
Just that channel is public. What you have to do is just here in the
search
bar.
Okay.
Look for that. Just type this, the hashtag, and it will show. Just try that now. Try now. Let's see what happens. So guys, try that now if you're not in this channel. Right? You should find it. It's this one. AWS exam.
Thank you.
Join. Once you find it, join your channel. And then you will be able to see them. Okay. Okay. So let's talk about them. Okay. Pillar organization, the best practice. Okay. Best practice of this guy. So identity and access management. So that's an example. So each pillar will include a set of design principles and best practice areas, right? A set of foundational questions is under each best practice, and some context and a list of best practices are provided for each question. So identity management, the question is, how do you manage credentials and authentication? That will be a question, right? In the well-architected framework tool. There's a tool for that you can find in AWS, right? And it's going to ask you questions to measure the success of your business, okay? If you're following the well-architected framework, right? So question context, credential and authentication mechanisms include passwords, tokens, and keys that grant access directly or indirectly in your workload. Protect credentials with appropriate mechanisms to help reduce the risk of accidental or malicious use. What are the best practices? Well, define requirements for identity and access management. Secure AWS account root user. Enforce use of multi-factor authentication. Automate enforcement of access controls. Integrate with centralized federation provider. Enforce password requirements. Rotate credentials regularly. Audit credentials periodically. So those are best practices when it comes to identity and access management. Okay. And, that will answer the question, how do you manage credentials and authentication? Right. So that's type of questions is what you will find in the well-architected framework tool. Okay. Now, we have here, right? This is the background of a company whose architecture you will be reviewing, okay? Or talk about it, not review, talk about it, okay? So any corporation was founded in 2008 by John Doe. It sells high-quality 3D printed cityscapes of neighborhoods that enable you to see individual buildings and trees. The cityscapes are printed in color with brickwork, roofs, gardens, and even cars in the correct coloration. The company is about to apply for private investment to fund their growth until their initial public offering. John and the board have asked you to perform an independent review of their technology platform to make sure that it will pass the due diligence. John was interested in using cloud computing from the start. So in 2008, he created an account with AWS and spun up his first Amazon Elastic Compute Cloud, EC2 instance. Over the years, the architecture of the Any Company platform has evolved. John now has a team of 5 technologies who write and operate all the technology in their organization. John still writes core code for extracting structure from motion, but he has given the AWS account root user credentials to the rest of his team to manage. Do you guys think that's wise to give the rest of your team your root account credentials?
No, you should limit it the most possible.
Create
Actually, you should ever give it to anyone. Anyone. Not only limit it the most possible. No, you don't give it to anyone. That's the root account. What do you do instead?
Users or groups?
Users and groups.
Correct. I create IAM users, right? And I give them administrator privileges, right? But my root account, I don't give my credentials to anyone, right?
Where does it say root account on this?
Sorry?
Like where in this it says root account? Like I don't see it.
Where? What do you mean? This?
Yeah.
No, it's just my notes.
Oh.
It doesn't say here. I just have some notes about some background of what's going on with John Doe. Okay, it's not here. It's not here. You don't see it here, right? But he shared the root credentials with his team. The root account credentials. That's bad practice. You don't do that, right? Instead, you create IAM users and give them access both programmatically and to the console, right? And make them administrators. Put them in a team, in a group of admins. That's what you do. You don't share your credentials with anyone. When you see that in the test, disregard that immediately. That's not an option, right? Now, any company corporation has 3 main departments: fly and snap, right? That's the one that does the image acquisition, pre-processing, and storage, right? You have show and sell. It's the one that does the promoting, selling, and working with customers, and make and ship, manufacturing of products and delivery. So the high-level design for the Any Company platform looks like the organizational structure of the company, right? Let's continue talking about it. Now, we have here Fly and Snap, the Fly and Snap department, okay? So multiple devices, currently camera and video cameras, are mounted on lightweight aircraft that capture imagery of major cities, including famous locations on a scheduled basis. Each device generates imagery assets that are time-stamped with a clock that is synchronized with the aircraft's clock. So the imagery assets are streamed to the onboard capture machine that has an external storage array. Okay. I'm just, guys, reading what I have here about what's going on here in this department. Okay. So the capture machine It's also connected to the aircraft's flight system and continuously captures navigation data, such as global positioning system, GPS data, compass readings, and elevations. When it returns to base, the storage array is disconnected and taken into an ingest bay. Here, the storage array is connected to an ingest machine. The ingest machine creates a compressed archive of the storage array and uses File Transfer Protocol, FTP, to send it to an EC2 instance preprocessor machine. Okay, this is an EC2 instance. After the storage array has been processed, the archive is written to tape for backup. The storage array is then cleared and ready for the next flight. Tapes are held offsite by a third-party backup provider. The preprocessor machine periodically processes new data sets that have been uploaded to it. It extracts all the imagery assets and stores them in an Amazon Simple Storage service, right? In an S3 bucket. It notifies the imagery service about the files and provides it with the flight information. The imagery service uses the flight information to compute a 3D orientation and location for every moment of the flight, which it correlates to the imagery file timestamp. The information is stored in a relational database management system that is based in Amazon EC2 with links to the imagery assets in Amazon S3. So that's what's happening in this section here. Now, about show, about, here. Yeah, I just jumped this, okay. Show and sell. Well, show and sell, when customers visit any company website, they can see images and videos of the physical product, right? These images are in a variety of formats. For example, a large scale walk around map. The website uses elastic load balancing with HTTPS and an auto scaling group of EC2 instances that run a content management system. Static website assets are stored in an S3 bucket. Customers can select a location on a map and see a video preview of their cityscape. Customers can also choose the physical size of the map, choose the color scheme available in white, monochrome, or full color, and have the option to place light emitting diode, LED, holes in the map to build illuminated maps. The mapping service correlates the map location input from the website with the imagery service to confirm if imagery is available for that location. If the customers are happy with the preview, they can order their cityscape. Customers pay by credit card. Credit card orders are processed by a certified third-party payment card industry, PCI compliant provider, and any company does not process or store any credit card information. That's very smart. After the website receives payment confirmation, it instructs the order service to push the order to production. Orders, including customer details, are recorded in the show and sell database, which is a relational database management system that is based in Amazon EC2. Okay. To initiate a video preview or full print of an order, the orders service places a message on the production queue. Okay. which allows the render service to indicate when a preview video is available. The order service also reads from the order status queue and records status changes in the show and sell database. Customers can track their order through manufacturing and see when it has been dispatched, which is handled by a third party through the broker dispatch service. Okay. Make and ship. Any company has proprietary technology that enables it to generate 3D models from a combination of photographs and video, extracting structure from motion. So the render service is a fleet of G2.2x large instances. That's a type, that's an instance type. Okay. The render service takes orders from the production queue and generates the 3D models that are stored in an S3 bucket. The render service also uses the 3D models to create flyby videos so that the customers can preview their orders on the any company website. These videos are stored in a separate S3 bucket. So once a year, the team deletes all previews. However, models are kept in case they are needed for future projects. After a customer places an order, a message is placed in the print queue with the link to the 3D model. At each stage of the make and ship process, order status updates are posted to the order status queue. This queue is consumed by the any company website, which shows the order history. The make and ship team has 4 3D printers that print high resolution and detailed color control models. An on-premises print conductor machine takes orders from the print queue and sends them to the next available printer. The print conductor sends order updates to the order queue, order status queue, and the print conductor sends a final update when the order has been completed, passed quality assurance, and is ready for dispatch. So as you can see, it's just an overview of this any company architecture that you see how this machinery works, and you can have an idea how complex a system that uses AWS can be. Okay, but that's how it works in this architecture. Okay, and if you take a look at it, it just it takes some thinking to create this architecture. Okay, of course, there's some of the services and appliances that this company has, like the printers, the 3D printers, but this is just the architecture in the cloud, right? Okay. So, operational excellence pillar. Let's talk about the first one. Well, the focus of this guy, right?
Mr. Atano,
Yes, go ahead.
we're not going to have the breakout session?
No, we're gonna do. We don't have time for that. Don't worry.
Okay.
About it. We don't have time for that. Okay. So, the operational excellence pillar, it focuses on the ability to run and monitor systems to deliver business value and to continually improve supporting processes and procedures, right? The key topics, as you see here, is automating changes, responding to events, defining standards to manage daily operations. So basically, what you do when you have operational excellence is just deliver business value to your customers. That's what you do with operational excellence. All right? Let's talk about it a little bit more. Okay, so there are 6 design principles for operational excellence in the cloud. The first one is perform operations as code. Okay, so what happens here? Well, you define your entire workload, that is the application and the infrastructure, as code and update it with code. And what is the service that it is called infrastructure as a code? You guys remember?
Cloud formation.
Cloud formation, very good. So implement operations procedures as code and configure them to automatically trigger in response to events. So by performing operations as code, what happens is that you limit the human error and enable consistent responses to events. Okay, that is the advantage of using perform operations as code. So the second one is make frequent small reversible changes. So you have to design the workloads to enable components to be updated regularly. So make changes in small increments that can be reversed if they fail without affecting customers when possible, right? The other one is refine operations procedures frequently. Look for opportunities to improve operations procedures. Evolve your procedures appropriately as your workloads grow, right, and evolve. And set up regular game days, right, to review all procedures, validate their effectiveness, and ensure the teams are familiar with it. So, guys, you know what game day is? Game day. Well, a game day is a day that AWS created for companies to train their personnel, right, and simulate real time or real life situations, right? And what would you do if this happened? How do you react to this? How would you respond to events? And you can select a day for that, right? To simulate special. Let me just put here, right? So a game day is a collaborative learning exercise that tests skills in implementing AWS solutions to solve real-world problems in a gamified, risk-free environment. This is a completely hands-on opportunity for technical professionals to explore AWS services, architecture patterns, best practices, and group cooperation. Okay, that's what a game day is. Companies do that. Okay, not only AWS partners or companies that use AWS, like customers from AWS. Well, the other one is anticipate failure. Okay, so you need to identify potential sources of failure so that they can be removed and mitigated before they happen, right? So you need to test your response procedures to ensure that they're effective and that teams know how to run them. Okay? Also, for this, you can set up regular game days to test workloads and learn responses to simulated events. Okay? Last one but not least, learn from all operational failures, right? So drive improvement through lessons learned from all the operational events and failures, right? Share what is learned across teams and through the entire organization. So those are the things that you can have, consider the design principles that you consider when trying to accomplish operational excellence. So the foundational questions for operational excellence fall under three best practices areas: organization, prepare, operate, and evolve, right? Now, operational teams must understand business and customers' needs so that they can effectively and efficiently support business outcomes. Operation teams create and use procedures to respond to operational events and validate the effectiveness of procedures to support business needs. Operation teams collect metrics that are used to measure the achievement of desired business outcomes. Right? And as business context, business priorities and customers' needs change over time. It is important to design operations that evolve in response to change and to incorporate lessons learned through their performance. So some of the questions for the organization is, how do you determine what your priorities are? How do you structure your organizations to support your business outcomes? How does your organizational culture support your business outcomes? Okay. For prepare, how do you design your workload so you can understand its state? How do you reduce defects? Is remediation and improve flow into production? How do you mitigate deployment risks? How do you know that you're ready to support a workload? And operate, how do you understand the health of your workload? How do you understand the health of your operations? How do you manage workload and operations events? And how do you evolve operations? Okay.
Mr. Atano.
Yes.
This slide is different from what's on Nearpod.
Really?
Yeah. The organization section is not there any at all.
Oh.
But continue. We'll talk about that later.
Yeah. Still you having the video. So that's weird. Okay. It's weird. Okay. So do you have this one?
Yes, it's there.
Okay. So this is the entire thing, okay, of any company. Again, okay. Now let's talk about the security pillar, right? The security pillar, the focus is on protecting the information, system, and assets while delivering business value through risk assessment and mitigation strategies. The key topics are protecting confidentiality and integrity of the data, identifying and managing who can do what, and protecting systems, establishing controls to detect security events. Okay, so far we have the operational excellence, which is to deliver business value. And now we have the security pillar, which is to protect and monitor systems. So we're trying to cover every aspect of your architecture. Okay, now let's talk about that a little bit more. Okay. So there are 7 design principles. We talked about the design principles for the operational excellence, right? Now we're going to talk about the design principles for security. There are 7 of them, and you can see them in the screen, right? So the first one is implement a strong identity foundation. Right? So how do you implement that? Okay. So the first thing that you have to do is implement the principle of least granting affirmations. In other words, the principle of least privilege. Okay. And on top of that, you have to enforce the separation of duties with appropriate authorization for each interaction with your AWS resources, right? Now, centralized privilege management is one of the things that you have to do, and also reduce or even eliminate reliance on long-term credentials. You want to rotate the credentials every 60, every 90 days, right? You don't want long-term credentials forever, right? That's very inefficient because, things may get that password. I mean, people may get that password. You want to rotate that. So every now and then, people, when they have your credentials that just stole your credentials from you, if they're rotated every now and then the person would have to hack into your system again and get the credentials again, right? Because they were rotated. Okay. It may be a little annoying, right? For you, right? To be rotating your credentials every 3 months, but that's the way it should be, right? Now, the other one is enable traceability. And we see this, you think about CloudTrail. CloudTrail is the service that performs the traceability in your account, right? So you have to monitor, alert and audit actions and changes to your environment in real time, right? Integrate logs and metrics with systems to automatically respond and take action, right? The other one is apply security at all layers, right? So you have to apply defense in depth, right? And apply security controls to all layers of your architecture. For example, edge network, virtual private cloud, subnet, and load balancer, and every instance, operating system, and applications. Remember security groups, tackles, all those guys? You have to apply security at all layers. The other one is automate security best practices. So automate security mechanisms to improve your ability to securely scale more rapidly and cost effectively. Right? Create secure architectures and implement controls that are defined and managed as code in version control templates, right? Remember, CloudFormation, right? Protect the data in transit and at rest. So classify your data into sensitivity levels, right? And use mechanisms like such as encryption, tokenization, and access control when appropriate. Okay. Now keep people away from the data. You need to reduce the risk of loss or modification of sensitive data due to human error. Create mechanisms and tools to reduce and eliminate, So I was saying to keep people away from data. So you have to create mechanisms and tools and try to eliminate the need for direct access or manual processing of data. So people away from it, right? As much as possible. And also you have to prepare for security events, right? You have to have a process that manages incidents, right? And it has to align with organizational requirements. So as a routine, you need to run incident response simulations and use tools with automations to increase your speed of detection, right? Investigation and recovery. So you have to move as fast as possible. Remember, there's a lot of things at stake when your system is compromised, right? I don't know if you have this one. Do you have this one, guys? Do you have this slide?
Yes, but it's different.
Oh, that's weird.
Security is not there.
That is weird. Okay. So.
And incident response is different.
This one?
Yes.
All right. All right, security. How do you securely operate your workload? That's going to be a question. Okay. Identity management. How do you manage identities for people and machines? How do you manage permissions for people and machines? Okay, identities and permissions. Detection. How do you detect and investigate security events? Infrastructure protection. How do you protect your network resources? And how do you protect your compute resources? Data protection. How do you classify your data? Is it sensitive, not sensitive? What is the level of sensitivity of this data? How do you protect your data at rest? Do you enable server-side encryption, right? How do you protect your data in transit? Incident response, right? Sorry. how do you anticipate, respond to, and recover from incidents? So the foundational questions for security fall under this 6 best practices, right? Before you architect any system, you must put security practice in place. You must be able to control who can do what, right? Who can do what? Also, you must be able to identify security incidents, protect your systems and services, and maintain the confidentiality and integrity of data through data protection. You should have a well-defined and practiced process for responding to security incidents. These tools and techniques are important because they support objectives such as preventing financial loss or compliant with regulatory obligations. Okay. Now, this is the same thing, the whole architecture of this guy. Right. Let's see the reliability pillar. So we've seen the operational excellence, we've seen the security one, and now we see the reliability pillar. Okay. So this guys mainly focuses on ensuring the workload performs its intended function correctly and consistently when it's expected to. A resilient workload quickly recovers from failures to meet business and customers' demand. Some of the key topics are designing distributed systems, recovery and planning, handling change, it's just recover from failure and mitigate disruption. So operational excellence, we just deliver business value. With security, we monitor the systems and appliances. And then with the reliability pillar, we make sure that we can recover from failure and mitigate disruption. Okay, that's the main focus on this guy. Okay. Yeah. Okay, I wonder what happened with the. Can someone share the screen to see what you see in the Nearpod? Because that's weird.
Enable, and I'll show it to you.
Yeah, please. Let me see.
It's not that big of a difference, but there are differences.
Go ahead.
So focus is different from the slides that you have. I think the key topics are also different. I noticed also that incident response was different from yours, and detective controls was different from yours. So a lot of the slides are different. The content is different in the slides.
What I'm gonna do,
but push on. To be honest, let's just continue.
but let me do something real quick. All right, let's continue. All right, so you guys can watch the video later. And I don't know why this happened. Yeah. Another one that I load this on a Nearpod. Okay. Let me see how can you stop sharing? Thank you. Guys, I will provide, when we finish the class, I will provide the actual ones for you. Okay. Don't worry about that. For now, you can follow me. Okay.
Okay.
So let's talk a little bit about this guy. Okay. So we have 5 design principles for the reliability pillar. Okay. So the first one is automatically recover from failure. Okay. So monitor systems for key performance indicators and configure your systems to trigger an automated recovery when a threshold is reached. This practice enables automatic notification and failure tracking, and for automated recovery processes that work around or repair the failure. Okay. The second one is test recovery procedures. Test how your systems fail and validate your recovery procedures. This is what we call penetration testing. Okay. Use automation to simulate different failures or to recreate scenarios that led to failure before. So this practice can expose failure pathways that you can test and rectify before a real failure scenario takes place. So you want to do that, in advance, right? Ahead of time. Now, very important, scale horizontally to increase aggregate workload availability. Okay. Replace one large resource with multiple smaller resources and distribute requests across these smaller resources to reduce the impact of a single point of failure on the overall system. So in other words, instead of having a big instance, have 10 instances that are small, right? And accomplish the same thing, right? Because remember, one instance is a single point of failure, right? If that instance fails, what's going to happen to the system? Gone, down, right? So you're going to have 10 instances that are small, right? And then that way you're going to increase your availability, right? And you're going to be able to recover faster than that, okay? So stop guessing capacity. That's one of the 6 advantages of cloud computing, right? So monitor demand and system usage and automate the addition or removal of resources with auto scaling to maintain optimal level for satisfying demand. So in other words, use auto scaling and forget about guessing capacity. That doesn't exist anymore. Okay. The other one is manage change in automation. So manage change in automation, you have to use automation to make changes to infrastructure and manage changes in automation, right? So automation is very important. It can give you a false sense of security because people rely on automation, but everything fails. Don't forget that. So keep an eye on automation, supervise it, right? Because it may fail as well. Everything fails. Don't forget that. But people feel secure. Oh, this is being automated, so I don't have to worry about that. No. Take a look at it, observe it, keep an eye on it, watch it, because everything fails all the time. Don't forget that. So these are some of the foundational questions of reliability, right? And they just fall under this best practice areas: foundations, workload architecture, change management, and failure management. Okay. So if you want to achieve reliability, a system must have both a well-planned foundation and monitoring in place. Okay? It must have mechanisms for handling changes in demand or requirements. And it should be designed to detect failure and automatically heal itself. That has to be there if you want to be reliable, right? So what are the questions? How do you manage service quotas and constraints? Do you have any limitations, right? You have some limits imposed to you. You have hard limits, soft limits. How do you manage that? Okay. And how do you plan your network topology? What kind of topology are you using? How are you using? Are you using mesh topology? Are you using star topology? What kind of topology are you using? So if you take a look at the, maybe here, let me see if I can. Okay, I cannot. Okay, no. So you can go online and just type topology, network topology. You see it. I cannot move the screen now. I will have to stop this. But network topology is just the layout of your network, right? So how do you lay your network out, right? For workload architecture, how do you design your workload service architecture? How do you design interactions in the distributed system to prevent failure? How do you design interactions in the distributed system to mitigate or withstand failures? In change management, how do you monitor workload resources? How do you design your workload to adapt to changes in demand? How do you implement change? Failure management, how do you back up data? How do you use fault isolation to protect your workload? How do you design your workload to withstand component failures? How do you test reliability? How do you plan for disaster recovery? So some of the questions that you guys can, when you are architecting, if you ever become an architect, right, in the cloud, these are some of the questions that you can ask a business owner, right, or a company to see how you can implement that in the cloud, right? And you can make your system as reliable as possible because you want your system to react, respond properly, appropriately, and recover from failure just in case there's a failure, right? So some of the questions that you guys can have, right? So we said that when we speak about operational excellence, what are we trying to do is deliver business value, right? And have these design principles, right? When we talk about security, we want to protect and monitor systems, right? And think about these design principles, right? And when we talk about reliability, we want to recover from failure and mitigate disruption as quick as possible. And then we think about these design principles. Okay. Now let's talk about the other one, which is performance efficiency, right? Now this one, what is the main focus of this guy? Well, the ability to use IT and computer resources efficiently to meet system requirements and to maintain that efficiency as demand changes or technologies evolve. What are the key topics? Well, selecting the right source types and sizes based on workload requirements, monitoring performance and make informed decisions to maintain efficiency as business needs evolve. And what is the focus of this guy? The main focus is just use resources sparingly. Okay, use these resources sparingly. Okay, so there are 5 design principles that can improve efficiency, and they are democratize advanced technologies. What is the meaning of that? Well, you have to consume technologies as a service. For examples, technologies like NoSQL databases, media transcoding, and machine learning require expertise that is not evenly dispersed across the technical community. So in the cloud, these technologies become services that teams can consume, right? So consuming technologies enables teams to focus on product development instead of resource provisioning and management, right? The second one is go global in minutes. Well, you can deploy your systems in multiple regions, and we know that from previous classes, in multiple regions to provide lower latency. And also you can also provide better customer experience at minimal cost. Right? The other one is use serverless architectures. Well, these guys will remove the operational burden of running and maintaining servers to carry out traditional compute activities. Serverless architectures can also lower transactional costs because managed services operate at cloud scale, right? And then you don't have to worry about anything that has to do with servers. AWS will take care of that. Now, experiment more often. Well, perform competitive testing of different types of instances, storage and configuration. Explore, experiment with your services and the different services that AWS offers. Right? And consider mechanical sympathy. Well, use technology approach that align best to what you're trying to achieve. For example, consider your data access patterns when you select approaches for database or storage. So that's what mechanical sympathy is. Right? Think about how much compute you are using on a daily basis so you can choose the appropriate instance type, right? Or EC2 instance type, right? So that's mechanical sympathy. These are the foundational questions for performance efficiency, and they fall under these 4 best practice areas, right? Selection, review, monitoring, trade-offs, okay? What time is it, guys? It's 10:03?
10:03.
Okay. So we use data to design and build a high-performance architecture. So what we need to do is gather data, right? And every aspect of the architecture, and from the high-level design to the selection and configuration of resource types. And then we review the choices that we have periodically to make sure that you are taking advantage of the new AWS services. Remember that AWS is always renewing services, right? And then after that, or on top of that, you can perform monitoring so that you can be aware of any deviance from expected performance, and you can take prompt action to remediate those, right? And finally, you can use trade-offs in your architecture to improve performance, such as using compression, using caching, or maybe you can relax consistency requirements, okay? Just trying to find trade-offs, like finding a balance, right, in your accounts. So these are some of the questions that you can ask, like, how do you select the best performing architecture? Okay. How do you select your compute solution? How do you select your storage solution? How do you select your database solution? How do you configure your network solution? Review. How do you evolve your workload to take advantage of the new releases? Monitoring. How do you monitor your resources to ensure they are performing? Trade-offs. How do you use trade-offs to improve performance? Guys, you don't need to answer these questions, just questions that you can ask yourself and the company you're working for if you want to achieve performance efficiency, okay? So the answers will give you a measurement of how well you're performing, right? Same architecture again. Let's talk about the last pillar of the well architecture framework, okay? And it's cost optimization. Cost is very important, always very important, right? Okay, so customization, the focus is on the ability to avoid unnecessary costs. And the key topics are the ones that you see here in your screen: understanding and controlling where money is being spent, selecting the most appropriate and right number of resource types, analyzing spend over time, scaling to meeting business needs without overspending. And basically what you're doing is just eliminating unneeded expense, right? Let's talk about a little bit more. Okay. So these are the 5 main design principles of the cost optimization pillar. Well, when it comes to implementing cloud financial management, so I'm sure you want to achieve financial success and accelerate the business value in the cloud, right? So you need to invest in cloud financial management and cost optimization. You need to build capability through knowledge building, programs, resources, and processes to become a cost-efficient organization, right? You have to be able to manage that. Also, you need to adopt a consumption model. Right? You pay only for the computer resources that you require. You don't want to pay for something you don't need, right? And increase or decrease usage depending on business requirements, not by using elaborate forecasting, right? Measure the overall efficiency. Okay? You have to measure the business output of the workload and the costs that are associated with delivering it. You can use this measure, right, to know the gains that you make from increasing output and reducing costs. Stop spending money on undifferentiated heavy lifting. AWS does the heavy lifting of racking, stacking, and powering servers, which means that you can focus on something else, your customers, business projects, instead of IT infrastructure, right? And the last one, but not the least one, analyze and attribute expenditure. The cloud makes it easier to accurately identify system owners and system issues, right? And costs and usage, and attribute IT costs to individual workload owners. So having this capability help you measure return on investment and gives workload owners an opportunity to optimize their resources and reduce cost, right? By analyzing and attributing expenditure. These are the foundational questions for cost optimization, and they fall under these 5 best practice areas: practice cloud financial management, expenditure and usage awareness, cost-effective resources, manage demand and supply resources, and optimize over time. So similar to the other pillars, there are trade-offs, right? There are trade-offs to consider when evaluating cost. For example, you may choose to prioritize for speed, going to the market quickly, shipping new features, or simply meeting a deadline, instead of investing in upfront cost optimization. As another example, designing an application for a high level of availability typically costs more. The more available you are, the more you're going to pay, right? So you should identify your true application needs and use empirical data to inform your architectural design decisions, right? Perform benchmarking to establish the most cost optimal workload over time. So on the practice cloud financial management, the question that should be asked is, how do you implement cloud financial management? How do you manage your finances in the cloud? Under expenditure and usage awareness, how do you govern usage? How do you monitor usage and cost? How do you decommission resources when you don't need them anymore? Okay. Cost-effective resources. How do you evaluate cost when you select services? How do you meet cost targets when you select resource type, size, and number? How do you use pricing models to reduce cost? Are you reserving? Are you using on-demand or spot instances, right? Are you reserving for 1 year, 3 years? How do you use pricing models to reduce cost? How do you plan for data transfer changes? Under the manage and demand and supply resources, how do you manage demand and supply resources? Optimize over time. How do you evaluate new services? So these are the foundational questions for cost optimization. Great. So basically, the AWS Well Architected tool, what it does is help you to review the state of your workloads and compare them to the latest AWS architectural best practices. It gives you access to the knowledge and best practices used by AWS architects whenever you need it, right? So the tool is available in the AWS Management Console. You can type in the services AWS Well Architected Framework, Well Architected Tool, and you will find it there. You see a bunch of questions there that you have to answer. It's a guide. It's mostly a guide, right? You define your workload and answer a series of questions in the areas of operational excellence, security, reliability, performance, efficiency, and cost optimization, right? As it is defined in this lesson that we have in today, right? Then after you have answered all the questions, this tool delivers an action plan, right, with a step-by-step guidance on how to build better workloads for the cloud. So basically, it gives you some recommendations for you. Right? And finally, it provides a consistent process for you to review and measure your cloud architectures. Okay. So the key takeaways here is the AWS Well Architected Framework provides a consistent approach to evaluate cloud architectures and guidance to help implement designs, right? The AWS Well Architected Framework documents a set of foundational questions that enable you to understand if a specific architecture aligns well with cloud best practices. And the AWS Well Architected Framework is organized into 5 pillars. Each pillar includes a set of design principles and best practices. Any questions, guys?
No.
It's a lot of theory, guys, for you guys to understand the Well Architected Framework a little bit more. Right? Let's talk about reliability and availability. What the CTO of Amazon.com say? He said, everything fails all the time. That's Werner Vogel, the CTO of Amazon.com. Okay. So in the words of this person, everything fails all the time. So one of the best practices that is identified in the AWS Well Architected Framework is to plan for failure or applications workload downtime. So one way to do that is to architect your application and workloads to withstand failure. There are 2 important factors that cloud architects consider when designing architectures to withstand failure, and they are reliability and availability. Okay, let's talk about the first one now. What is reliability? Well, it's a measure of your system's ability to provide functionality, right, when desired by the user, right? So because everything fails all the time, you just think of reliability in statistical terms. Right? Reliability is the probability that an entire system will function as intended for a specific period. Right? Note that a system includes all system components, such as the hardware, the firmware, and the software. So failure of system components impacts the availability of the system, right? So to understand reliability, it is helpful to consider the familiar example that you see here, this car here. The car is a system. So each of the car's components, right? Car components, the cooling, the ignition, the brakes, all that, right? must work together in order to make the car work properly. Okay. Now, if you try to start the car and the ignition fails, you cannot drive anywhere, right? And the car is not available. If the ignition fails repeatedly, your car is not considered reliable, right? Your car is not reliable if it starts failing. Okay. Now, a common way to measure reliability is to use statistical measurements, such as the mean time between failures, MTBF, and that's the total time in service over the number of failures. Okay, so you divide the total time in service by the number of failures, and then that will give you the mean time between failures. Okay. Right. Now, say that you have an application that you bring online Monday at noon, right? The application is said to be available. It functions normally until it fails Friday at noon. Therefore, the time to failure, or the length of the time that the application is available, is 96 hours. You spend from Friday at noon until Monday at noon diagnosing why the application failed and repairing it, at which point you bring the application back online. Therefore, the time to repair is 72 hours, right? Then it happens again. The application fails on Friday at noon. You spend from Friday at noon until Monday at noon repairing it, and you bring it online on Monday at noon. So say this failure, repair, restore cycle happens every week. You can now calculate the average of these numbers. In this example here, the mean time to failure is 96 hours, right? And your mean time to repair, which is MTTR, is 72 hours. Your mean time between failures, MTBF, right? MTBF will be 168 hours, or 1 week, which is the sum of MTTF and MTTR. That's the mean time between failures. So that's happening every single week. Okay. So you can do that in statistical terms to be able to measure how reliable your system is. Okay. So the availability, on the other hand, this is reliability. The availability, on the other hand, is the normal operation time divided by total time, right? So as we saw, failure of system components impact the availability of the system, right? So formally, availability is the percentage. Just give me a second, guys. Sorry, guys, someone's knocking on the door. So, like I was saying, availability is just the percentage of the time that the system is operating normally or correctly, performing the operations expected of it, right? Or simply the normal operations times over total time. Right? Now, availability is reduced. Anytime that the application is not operating normally, right? Including both scheduled and unscheduled interruptions, right? Also, availability is it's defined as the percentage of uptime, that is the length of time that a system is online between failures over a period of time, commonly 1 year, right? For example, a percentage of time, let's say 99.9% over time, for example, 1 year, right? So the number of nines, it's a very common way to refer to availability. It's a common shorthand, right? For example, 5 nines means 99.999% availability. Okay, that's how you can see that in another way. Okay. High availability. Well, this was availability. Now we're talking about high availability, right? A highly available system, it's one that can withstand some measure of degradation while still remaining available. Right? It is in a highly available system, downtime is minimized, right? As much as possible, and minimal human intervention is required. So a highly available system can be viewed as a set of system-wide shared resources that cooperate to guarantee essential services. High availability combines software with open standard hardware to minimize downtime by quickly restoring essential services when a system, component, or application fails. Services are restored rapidly, often in less than a minute, when your system is highly available. Okay? There are different high availability tiers, and these are the ones. Okay? So, when your system is available for 99%, which means per year, right? In a year representation, the maximum disruption is 3 days and 15 hours. Okay? I believe that 99% is a long disruption. Very long disruption, even though it is, it's 90%. Okay. So the length of disruption that is acceptable depends on the type of application, right? We have applications here, right? This table, it's just a representation that things of synthesis can occur in a year. And you still meet the goal. You still meet the goal, because if you go for 99%, you go for that, aware that that's the disruption that you're going to have per year, right? Right? Now, the applications that can have this, availability is batch processing, data extraction and transfer and load jobs, okay? And we're talking about the cloud here, okay? Now, 99.9% is 8 hours and 45 minutes, right? So that's for internal tools like knowledge management and project tracking. Then we have 99.95%. That's 4 hours and 22 minutes. That's for online commerce and points of sale. 99.99 is 52 minutes per year. That's very low. 52 minutes per year. Still, it's very low compared to this one, but still not good. 52 minutes, almost an hour down, not good. Okay, that's for video delivery and broadcast systems, right? And 5 nines, that's 5 minutes per year, right? ATM transactions, telecommunication systems. So that's the, when you have this, you're still meeting your goal, okay? This is something that you consciously and aware choose to have, this service level agreement. I believe that for mission critical applications, this is too high, okay? Even for Netflix, this is too high. 5 minutes down, too high, not good, okay? But if you think about it, it's per year, right? So if you have 1 day down for 5 minutes and you're not down ever anymore, you're good. I mean, you're great. That's awesome. Or maybe this can be, I mean, this was happens split throughout the year, like probably 50 seconds today, tomorrow, probably your next week is going to be 60 seconds. That will be 2 minutes. And then you go that way. I mean, all across the year. That's, I mean, I believe it's great, right? So can you imagine 11 nines, which is the durability of S3 buckets, of S3, which is 11 nines? You know what it means? It's once in 10,000 years. So that's crazy, right? But that's how high availability is measured in percentage, right? Now, let's talk about this guy here, and then we have a break, right? So, tough events that might disrupt an application's availability cannot always be predicted. You can build availability into your architecture design. That's true, but it's hard to predict sometimes, right? So there are three main factors that determine the overall availability of your application. That's fault tolerance, scalability, and recoverability, right? So this guy, the fault tolerance, it refers to the built-in redundancy of an application's components and its ability to remain operational even if some of its components fail, okay? So it will rely on a specialized hardware to detect failure in a system component, such as a processor, a memory board, a power supply, an input-output subsystem, or a storage subsystem. Okay? And it will instantaneously switch to a redundant hardware component. So the fault-tolerant model does not address software failures, which are the most common reason for downtime. Okay. The other one is the scalability, right? Is the ability for an application to accommodate increases capacity needs without changing design, right? It can remain available and perform within your required standards. It does not guarantee availability, but it contributes to your application's availability. Okay. The third one is recoverability, okay? And that's the ability to restore services quickly and without lost data, right? If a disaster makes your components unavailable or it destroys the data, right? It's just the ability to restore service quickly without losing data. Okay? Now, keep in mind that improving availability usually leads to increased cost, right? Like I said before, the more high available you are, the more you're going to pay, right? Now, when you consider how to make your environment more available, it is important to balance the cost of the improvement with the benefit to your users. The question would be, do you want to ensure that your application is always alive or reachable, or do you want to ensure that it's servicing requests within the acceptable level of performance? So what is the answer to that? So that's going to give you a better idea of what you really need in your application. Okay. Takeaways of this section, right? Well, reliability is a measure of your system's ability to provide functionality when desired by your user, and it can be measured in terms of MTBF. So median time before or between failures. I'm sorry, median time between failures. Availability is the percentage of time that a system is operating normally or correctly performing the operations expected of it, or normal operations time over total time. Three factors that influence the availability of your applications are fault tolerance, scalability, and recoverability. You can design your workloads and applications to be highly available but there's a cost trade-off to consider. Okay. Any questions, guys?
No questions.
It's been a lot of information, but it's just for you guys to understand that there are five pillars of the well-architected framework. You know, cost efficiency. Can you continue telling me? What are they?
Security, reliability,
Yeah,
performance, and cost optimization.
performance efficiency
Performance efficiency.
and cost optimization, and the other one is excellence, operational excellence. Okay, so guys, it's 10:33. Let's break. Let's break. Let's have a 15 minutes break. A 10 minutes break. I'm sorry, not 15. 10 minutes break, and then I'll meet you back here at what time is it? 10:33 at 10:45. Okay. Okay, guys, we're back. So, as you have learned so far, you can use the AWS Web Architecture Framework as you design your app architectures to understand potential risks in your architecture, or identify areas that need improvement, and drive architectural decisions. So in this section, you will learn about AWS Trusted Advisor, which is a tool that you can use to review your AWS environment as soon as you start implementing your architecture. Okay, so AWS Trusted Advisor is an online tool that provides real-time guidance to help you provision your resources, right, following AWS best practices. AWS Trusted Advisor, it will look at your entire AWS environment and give you real-time recommendations in 5 categories. Okay, cost optimization. See here that this has the same name as the pillar of the Web Architecture Framework. Okay, performance, security, just like the one from the pillar from the Web Architecture Framework, and performance as well. It's performance efficiency for the Web Architecture Framework. Fault tolerance is one of the factors of high availability, right? And service limits. It will give you the limits in your account. How many VPCs you can have, how many users you can create, how many groups you can create, how many EC2 instances you can have. So the limits, okay? Now, the cost optimization, right? It will look at your resources, right? At the use of your resources and make recommendations to help you optimize the cost by eliminating unused and idle resources, or by making commitments to reserved capacity. It will not do it for you. It will give you recommendations. So in your exam, when you see the word recommendations, what is the service that gives you recommendations to improve your architecture? That is Trusted Advisor. Okay. Performance, right? It improve the performance of your service by checking your service limits, ensuring you take advantage of provision throughput, and monitoring for overutilized instances, okay? EC2 instances. Security. Improve the security of your application by closing gaps, enabling various AWS security features, and examining permissions. Fault tolerance. Increase the availability and redundancy of your AWS application by taking advantage of automatic scaling, health checks, multi-AZ deployment, and backup capabilities. Service limits, well, AWS Trusted Advisor will check for services usage that is more than 80% of your service limit. Values are based on a snapshot, right? So your current usage might differ. We'll take snapshots of your usage. Now, the limit and user data can take up to 24 hours to reflect any changes. Right? So that's basically what AWS Trusted Advisor would do with your account. Okay. So let's interpret some recommendations from the Trusted Advisor. Okay. So let's say that you have a friend who used AWS Trusted Advisor for the first time, right? She or he's trying to interpret its recommendations to improve her cloud environment and needs your help. This is her dashboard, right? So what everything looks okay in the cost optimization and service limit categories, You notice that there are a few recommendations that you should review to help her improve her security, right? Performance, and fault tolerance. You see this red sign here is telling you there's a warning here. Well, the warning is this one. This one requires an action, the right one, the red one. Okay. So let's help our friend interpret the following, just the recommendations that we're going to see now. Okay. So there's a warning, or there's an action that you have to be performed in MFA on root account. Okay. It's very, very good to have MFA on your root account. And you have noticed that every time that I try to log into my account, I always use MFA, right? Because it's enabled in my account. Okay. So for this type of recommendation, questions that you can ask is, what is the status? Well, this status is requires an action, right? What is the problem? Well, MFA on root account, you don't have it. Right? What specific environment details are you given? Well, let's see here. Checks for the root account and warns if multi-factor authentication is not enabled. For increased security, we recommend that you protect your account by using MFA. Right? Which requires a user to enter a unique authentication code from their MFA hardware or virtual device when interacting with the AWS console and associated websites. Right? That's the description. And what is the alert criteria? What is this alert taking place? Is because MFA is not enabled on the root account. Right? So what is the best practice? Well, it's giving you here the recommendation action. Log in to your root account and activate an MFA device. In my case, I'm using Google Authenticator in my phone, and then the Google Authenticator provides a code to me, right? It provides a code to me, an authentication code, and then I enter it in my login section. Right? That's a recommendation here. Okay. It gives you the description of the problem. It gives you the alert. Why is the alert, happening, and what is the recommendation? How you can mitigate that. Right. Another one is just a warning. Password policy is not a requirement, but it's part of the best practices, and it may not affect your account. That's just a warning, right? But you should have it. Okay. So the description is checks the password. This is checking the password policy for your account and warns when a password policy is not enabled, or if a password content requires have not been enabled. Password requirements, content requirements, increase the overall security of the AWS environment by enforcing the creation of strong user passwords. So you can say the password requires an uppercase, requires a number, requires a special character, and it has to have a length between 8 and 16 characters. So that will be an example of a password policy. Okay. So when you create or change a password policy, the change is enforced immediately for new users, but does not require existing users to change the passwords. So why is this criteria happening where a password policy is enabled? Right? But at least one content requirement is not enabled. Right? That's why it's just a warning. What is the recommended action? If some content requirements are not available, consider enabling them. Right? If no password policy is enabled, create and configure one. See setting an account password policy for IAM users. All right. In the IAM section. Recommendation number 3. Security groups unrestricted access. So you're letting you know, a lot of people to access your account, right? Probably everybody, right? You see here the IP range here, 0.0.0.0/0. That means that every single IP in the world can SSH into my account. That's not good. This is fine. Port 8080, that's, you know, that's for web servers, right? And you can use all these zeros for web servers. Okay? So, description, it will check security groups for rules that allow unrestricted access to a resource. Unrestricted access increases opportunity for malicious activity, hacking, denial of service, and loss of data, right? The alert criteria, a security group rule has a source IP address with a /0 suffix for ports other than 25, 80, and 443. So those are the ports that regularly have /0, 25 for email, 80 for HTTP, and 443 is for HTTPS. So that's normal. But in this case, we have port 22. Not good. So it means that anyone can SSH into your account. Anyone can log in into your instance. That's not good. Okay? So what is the recommended action? Restrict access to only those IP addresses that require it. Right? Maybe your IP address only, or a specific range of people of your company. Right? To restrict access to a specific IP address, set the suffix to 32, which means only one address, and that is 192.0.2.10. That's an example. It could be your own IP address, but when you use /32, it means that only one IP address can access that, and that's the one that you specify. So be sure to delete overly permissive rules after creating rules that are more restrictive. In other words, guys, use the best practices when creating security groups. Okay. EBS snapshots. Okay. Well, we have a problem here, right? The most recent snapshot is between 7 and 30 days old. That's when it's yellow, right? That's a warning. Red, the most recent volume snapshot is more than 30 days old. It means that please take a new snapshot. Okay? Take a new snapshot. And the other one is the volume does not have a snapshot. Bad. That is bad. Why? Because you may need to restore that volume in the future if something happens. So you can restore your volumes from a snapshot. Okay? So the description is, checks the age of the snapshots for your Amazon Elastic Block Store, EBS, volumes, available or in use, both. Even though Amazon EBS volumes are replicated, failures can occur. Okay? You can replicate a volume, but it's going to be the same in every place when it's been replicated. So a snapshot is super important. Okay? And even if that availability zone where it's replicated is down, you lose the volume. So it's good to have a snapshot because it will be stored where? In an Amazon S3 bucket, which is highly durable, 11 nines, don't forget that, 11 nines. And also a snapshot is a point in time, right? It's a frozen image of your volume, and it will be extremely excellent for recovery, right? So what is the
Question.
why?
When you take a snapshot of an EC2 instance, does it QS the instance?
You take a snapshot of the volume. Okay? You don't create EC2 instances with volumes. You have to create an image, right? So what you can do is from Let me see. Let me show you guys. Let me show you. One moment. Okay. So let me go to my AWS account. Right. You see MFA now? It's gonna ask you for MFA, and you know that guy. You guys know that because I've done it before. Okay. Okay, so let me come here and create an EC2 instance. Okay. I don't have any right now, so I'm gonna create it. Just a quick one. I don't have to. I just move. See, I just launch it, and that's it. That's all I need. I don't have to go through everything. I just want to show you guys how to create an instance from an image, right? So right now, this instance is in the pending state. Okay. So just wait a few seconds. It will be running in no time. It's running. Okay, perfect. And if you take a look at storage, we have a volume here of 8 gigabytes, right? It's not encrypted, okay? And it will disappear when you terminate the instance, right? Now, I can come here to volumes and go to that area where that volume is. And here I can create a snapshot of that volume, right? So I can create a snapshot here. I can call it my Saturday snapshot, right? Create a snapshot, and that's it. Done. Okay, so the snapshot is being created now. It takes some minutes, probably up to a minute or two for that to be created, right? It depends on how big the volume is and how much data it has inside, right? So from this, I can create an image, right? Right? Or I can create a volume. So this is a snapshot, which I can save, which I will save, because if I want to save money, I will save it in an S3 bucket, right? In an S3 bucket. Then you can restore a volume from this, but you cannot create an EC2 instance for this. There's no option to do that, right? There's no option to do that. But you can create an image, right? And the image contains everything that you need to create an instance, right? It has the volume, it has the architecture here, it has the RAM disk, we're gonna use the default one, it has the kernel ID default, virtualization type, right? And then I'll call it my Saturday class image, right? And then I create the image, right? Oh, it's not complete yet, so I cannot do that yet. So let's wait for that to happen. You know, I don't know why it gives me the option. They should be graded out, you know? Okay, still pending. Let's continue, and then we come back to this. Okay. So these are the questions that you guys can ask yourself when this happens. Okay. So let me see. Yeah, I can come back. Okay. So the good practice recommendation from AWS is take it weekly or monthly, but take one, right? You know, yellow is between 7 and 30. Okay. Weekly is the best. It's the best of the best, right? It's the bestest one. Okay. Weekly snapshot. Okay. It's complete now. So I can come here and create another volume, right? Let me choose the general purpose. I can choose whatever I want. I can upgrade it, right? I can just scale it up if I want to. But now, do you remember that the volume was not encrypted? Remember? I can create an encrypted volume from the unencrypted volume, right? So now I can encrypt it and then create a volume, right? I'm just restore the volume from the snapshot. If I go to volumes, I see that the volume is in the creation and now is available. So I have a volume that is encrypted. If you can take a look here, it's encrypted. The other one was not encrypted, okay? This is a copy of this. But from this, I can attach it to an instance now, okay? So bottom line, from snapshots, you can recover volumes, okay? Now I can create an image from a snapshot if I want to. So I can say here, create image, give it a name, right? And then I can create the image, right? So now I can come here to the image section, my AMIs, right? And I can see that my image is available, right? From this, I can launch an instance. And then I do this, you see? The image is already being selected. So this step was skipped because the image was already selected. But I can start the process from zero, right? You see my Saturday class image here. It's been selected. Or I can come to my AMIs and you will see that that one is there. Okay, it's right here. If I unselect this, then I can come to my marketplace. You can see a bunch of images there, right? But my AMIs, I have this guy. So I select this guy. I continue the process. I just launch it, and it's gonna be an EC2 instance exactly the same as the other one, right? So now I have two instances that were created. One was created from an image from the quick starts, and the other one was taken from my AMIs, right? Now I can attach the volume that I created to an instance. Okay, let me see what is the availability zone of the volume that I created. 1:8. So you see this here? This volume can only be attached to an EC2 instance that was created in this availability zone. And you will see that the only EC2 instance that it will find is the one ending in 9368. It will not find the other one. Okay, so let me attach the volume to the instance. So I can come here, get the one in use, right click, attach volume, right? And then when I do this, I see that the one is 9368. It doesn't see the other one because the other one was created in availability zone 1B. So the volume has to be in the same availability zone as the instance if you want to attach it to it, right? So now I can do attach it. It's been attached. Now it's not available anymore. Right now is in use, right? So I can come back to my instance and see that when I click on this guy, and I take a look at storage, I see that I have two volumes attached to it. One is not encrypted and the other one is encrypted, which is the one that I created, okay? This one will not be deleted when the instance is terminated. The one that I created and the one that came with the instance will be terminated, will be deleted on termination. Let's see it. So let me delete that instance, the one ending in 9368. Let me terminate it, okay? And you will see how the volume will go away. The one that came with it, the unencrypted one, will disappear. It will delete it, will be deleted. But the one that I created, the one that is encrypted, will stay there until I delete it. And of course, I'm gonna be charged for it, for that volume that is there, okay? It's been shut down. Let me shut down the other one too. All right. So you guys understand the process of creating a snapshot from a volume
Yes.
and then restoring the volume from the snapshot
Yes.
and having the option to encrypt it in the process.
Yes.
And also you can create an image from the snapshot,
Yes.
and from the image you can launch instances. So that's the process. That's how it happens. So let me delete this image. I don't need it anymore either. I'm going to deregister. Okay, it's gone. Okay, now if I take a look at the volumes, I see only one, and this is the one that I created because it says here encrypted, right? This is the one that I created. It will go away when I delete it. Okay, so now it's in the process of being deleted. It's gone, right? So this is basically what's happening, what is happening here, right? You have to create a snapshot so you can restore your volumes just in case something happens, right? The other recommendation is bucket logging, okay? Bucket logging. So the description is it checks the logging configuration of Amazon Simple Storage Service, S3 buckets. When server access logging is enabled, detailed access logs are delivered hourly to a bucket that you can choose. So an access log record contains details about each request, right? Such as the request type, the resources specifying the request, and the time and date the request was processed. By default, bucket logging is not enabled. You should enable logging if you want to perform security audits or learn more about users and usage patterns. Criteria, yellow. The bucket does not have server's access logging enabled. The target bucket permission does not include the owner account. Trusted advisor cannot check it. Okay, those are things that can happen. Recommended action: enable bucket logging for most buckets. If the target bucket's permissions do not include the owner account and you want trusted advisor to check the login status, add the owner account as a grantee, right? Let me create a bucket. Let's see here. Let me create a bucket here. So right now I don't have any buckets. So I'm going to create a bucket, right? I'm going to call it AWS Saturday class access bucket. This is the bucket that's going to have the access created. Okay, so I can come here and just click on advanced settings and see here. Let me see. Okay, that's something that I can do later. Okay, not a problem. So the bucket has been created. Okay, now I can come here and come to properties and trying to find server access logging, right? But first, I'm going to create another bucket, which is the one that's going to log the information about the access to the previous bucket. So AWS Saturday class log bucket. Okay, this is the one that's going to contain the logs of access in the first bucket. So this bucket will contain all the logs of this bucket. Everyone that accesses the bucket is going to generate a log that's going to be stored here. Okay, so I'm going to come here and come to properties and look for the section says enable logging, so you can edit it, enable it, and then I'm going to put it in what bucket? You see, maybe S3. What was the name of the other one? Wait, S3, right? and I'm gonna say AWS Saturday class log bucket. Okay, and I'm gonna put it in a preface name, access logs. Okay, say that. Okay, perfect. So right now, when someone tries to access my bucket, this bucket here, right? Like some access, like from outside, right? Let me just upload something here, right? Let me upload a file. Anything that is not important. This one. Okay. So I'm going to make it enable server-side encryption. You see, access for other AWS accounts. Okay, so now I can upload that, right? So the file has been uploaded. Let me make it public. Okay, right now is not public. Okay. So I'm gonna make the bucket public. So this is the one, right? Properties. Okay, I think it's permissions, right? I'm gonna unblock this, right? And then I'm gonna save the changes. I'm gonna confirm, right? And now all the public access is not blocked, right? So let me go back to my objects, and I will give you the link to this, guys. See if you can download it. Okay. So I'm gonna post it in the chat and see if you can download that. Okay. Just let me if you can download that. Try to click on that.
Not possible for me.
Why not possible?
Access denied.
Access denied? Okay.
Yeah, it's denied.
Yeah, it means that I have to make the object public. Just give me 1 second. Okay. Try now, guys.
Yes, now it's possible.
All right. So try to do it several times. Just delete the one that you downloaded and do it again. Everybody do it, please.
It works. It works.
Okay. So delete the one that you downloaded and do it again. And let's see if it records all the access to that particular bucket. It may take some time to upload, to just show here the logs. So let's wait for that. So maybe later. So make sure that this has logging server access source enable. Okay, and the bucket is the access log. Let me make sure that this is the bucket name that we're talking about. Okay. Okay, so class log bucket. Yeah. Okay. Perfect. Perfect. Okay. All right. Let's wait. Let's wait. So, okay, takeaways of this section. AWS Trusted Advisor is an online tool that provides real-time guidance to help you provision your resources by following AWS best practices. AWS Trusted Advisor looks at your entire AWS environment and gives you real-time recommendations in 5 categories. You can use AWS Trusted Advisor to help you optimize your AWS Trusted Advisor as soon as you start implementing your architecture design. Right? Okay, the module wrap up. In summary, in this module, you learn how to describe the AWS well-architected framework, including the 5 pillars, identify the design principles of the AWS architected framework, explain the importance of reliability and high availability, identify how AWS Trusted Advisor helps customers, and interpret AWS Trusted Advisor recommendations. Good. Now to check. Question for you guys. Read the question, please. A sysops engineer working at a company wants to protect their data in transit and at rest. What services could they use to protect their data? Okay, the key words is the data in transit at a rest. Okay, what data can you use? Cecilia, that's your answer? All of the above? Okay.
Mine, C.
You say C?
Yeah.
Amazon Simple Storage, okay. S3. Any other one, guys? So what do you guys think?
D.
B and C are correct.
Yeah, load balancing, is that, how does that protect? That's more for performance, right? Than
It does protect it.
Yes, that's protect.
Does protect it. It has access logs.
oh, okay.
Yeah. So B and C are at rest. So I guess A is also in transit. So I guess the answer is D.
The answer is D. So this is the key. These are the keywords: data in transit, data rest. So if it says at rest only, then you say EBS and S3, right? And elastic load balancer. You can also enforce data encryption in transit with Amazon S3 as well. You can have a policy that only accepts objects that have been encrypted before they are stored in the S3 bucket. You can enforce that too. Okay, so it's not only the elastic load balancer. Okay. So that's the answer. Okay. So I'm going to paste this, okay, on Slack. And then that's it with this lesson.